Good morning, everyone. Welcome to the last couple of lessons to Chapter 5. Today we're going to be doing lesson 5.2.3, and the big picture question from Chapter 5 is, when are they the same? Okay? When are they the same? This is the real purpose of 8th grade math. Everything that we've been doing since August has been leading us up to today's lesson and tomorrow's lesson. Okay? When are they the same? These two things, when do they cross? When do they meet? When are they equal? When are they the same? And so today what we're going to do is we're going to start with what we know. So far in section 5.2, that's lesson 1 and 2. Remember Evie and Joyla, when do they meet? When do they get together? Okay, you've solved a system of equations by graphing two lines and finding where they intersect. When are they the same? However, it is not always convenient nor accurate to solve by graphing. You're going to kind of see that today in today's lesson. So we're going to do some work on your own first. So here we go. Chubby bunny, fat cat. You notice we've got a pretty chubby bunny over here. And the cat, it's a big cat. So we're going to use tables and a graph to find and check the solution to the problem below. You'll notice in your notebook, you have room to do the bunny and the cat, okay? Write the beginning value, the growth, all that sort of thing. We're going to do that, and then we're going to work on this page. So Barbara has a bunny that weighs 5 pounds, write the beginning value, and gains 3 pounds per year. That's the growth. If you know the beginning value and the growth, you can write the rule. Write the rule now. You should have written y equals 3x plus 5. Okay? That's the rule for our bunny. Her cat weighs 19 pounds. Write the beginning value. And gains 1 pound per year. That's the growth. So if you know the beginning value is 19 and you know the growth is 1, let's write the rule. You should have written y equals 1x plus 19. When will the bunny and the cat weigh the same amount? Notice, this is the big picture question. When are they the same? All right? So here's what I want you to do on your own. You already have this information filled out about the bunny, about the cat. What you need to do is go ahead and give me the rule or the table. Write the beginning value and grow it. Do that for the bunny. Do that for the cat. Give me a graph. And then you are going to go ahead and say, in blank years, both the cat and the bunny will both weigh blank pounds. You can write that on the graph. You can kind of write that in the lower left-hand corner. I want you to pause the video and get the table and the graph done. Do that now. Ready, set, go. Okay, welcome back. Now, you should have your table and your graph completed. Now, I don't know if you noticed this, but it doesn't match. There's not a matching number in the tables. It's on purpose. Now, when you did your dots and you ended out here, let's see, this is 0,5, and then 5, I believe 20, and the other one was 19, like 25. If you just drew line segments, they don't cross yet. And you've got to continue these out, but it's kind of ambiguous. It's not very clear where exactly they cross. And so the purpose of today's lesson is to extend this a little bit further. When tables or graphs are not accurate, what do we do? This is the purpose of today's lesson. In this previous problem, we wrote rules, right? And what we could do is we could use tiles, okay? But here's what I want you to write in problem 5-42. If we know this is the bunny, write the word bunny. And this is the cat, write the word cat, just like I did. And if you want to know when are they the same, all you got to do is put them equal to one another. So here we go. If the bunny equals the cat, we're going to write 3x plus 5. I want you to notice I'm writing it in a different order than the book. I don't like that. And the cat is 1x plus 19. And I want to know, big picture question, when are they the same? I just have to set them equal. This is the only thing I'm teaching new today. If you have two rules and you want to know when are they the same, put them equal to one another. Okay? So now I'm going back to September, October, November, solving equations. I need to do a side-side flip. And I'm going to flip this positive 1 over here, and it's going to become a negative 1. I'm going to side-side flip this guy. Over here, the positive 5 becomes negative 5. And I'm going to go ahead and do the math, and I get 2x equals 14. That's our first legal move, side-side flip. My next legal move, I'm going to do a regroup. A regroup is like division. Divide by 2, divide by 2. Now I know x is 7 years. Remember, the real world quantity that we're talking about here is in years. So in that sentence, check your work. In how many years? What did you write? Was it 7? Did you get that right? In 7 years, they will be the same. Now, this is only the second step. Step 1 was make them equal. Step 2, solve for x. The third step is we need to know how many pounds did they both weigh. So let's go ahead and follow this all the way through. And I believe this is still problem 42, so let's squeeze it in. Let's see if I can take this and scoot it over here so that I have room to write, because when I am solving for x, after I get my answer, x equals, I need to go back and check my work. 3x plus, don't write this yet, 3x plus 5 equals 1x plus 19. This is our original equation. And when we are checking our work, what we do is we say, we don't want this x. Instead of x, I want a parentheses. Now, I don't really like this 1 times parentheses, so I'm just going to put a parentheses in here. Now, I need to take my answer, x equals 7, and I'm going to put the number 7 inside that parentheses. This is how we learned how to check our work a couple chapters ago. Let's go ahead and do the math. 3 times 7 is 21. 21 plus 5 is 26. On the right-hand side, 7 plus 19 is 26. If you want to write a 26 right there, that's okay too. Check, I got it right. They are the same. In 7 years, they will both weigh 26 pounds. So some of you might have gotten this right, even though the graph wasn't accurate. Maybe you skip counted the table a little bit further. Maybe you just kind of knew where it was going. But in a moment, what if we're dealing with numbers that are so much larger? Okay? So what we are learning today is there are 3 steps. And I actually want you to write this right now on problem 5-45. 5-45. Ms. Harlow calls the method you have been using today to solve equations the equal values method. Explain why this name makes sense. We're just going to write down what the equal values method is. Okay? The equal values method, you're writing this right now, 5-45. The equal values method is solving a system of equations algebraically. Okay? The equal values method is solving a system of equations algebraically. Period. Okay? It requires 3 steps. It requires 3 steps. Step 1. Set the 2 rules equal to one another. Step 2, solve for x. Step 3, check your solution for y. Now, you're taking the x value and you're plugging them in, and that number that you get is the y, because remember, y equals the rule. So the equal values method is solving a system algebraically. Okay? It has 3 steps. Set the 2 equations equal to one another, solve for x, check your solution for y. Okay? So we're going to do 2 more problems doing this. Okay? Here we go. Post Falls, Idaho. Post Falls High School in Idaho has 1,160 students and is growing by 22 students per year. Richmond High School in Indiana has 1,900 students and is shrinking by 15 students per year. Okay, we're not going to graph it. We're going to create 2 rules, and we're going to figure out how many years it will take for them to be the same, and then we're going to figure out what the population is. So let's go ahead and record this information. I'm going to scoot this over here so that I have a little bit more room to work. All right, here we go. Y equals Post Falls, Idaho. Growing by 22 students per year and has 1,160 students. Richmond is shrinking. That tells us negative by 15 students, and they have 1,900. Okay? Step 1, when you are solving equations, step 1, set them equal to one another. So let's take 22x plus 1,160, and it is going to equal negative 15x plus 1,900. Okay, here's what you're going to do. You are going to pause the video. You might want a calculator. You're going to do side, flip, and a regroup. Write x equals. Pause the video. Find x equals. Okay, welcome back. Now you should have side, flip this that way, side, flip this way, and you will end up with x equals 20 years. Okay? You should have found that. I'm not doing all the work because I want you to be responsible for that work. Now, that was step 2. Step 1 was set it equal. Step 2, solve for x. Step 3, check for y. So I'm going to take my equation, and I'm going to write 22, but I don't write the parentheses, or x, I write a parentheses, plus 1,160 equals negative, make sure you include that negative, times plus 1,900. Now I'm going to take the number, what was my answer for x? X equals 20. Now you are going to have to follow the order of operations, and you're going to need to tell me what is the population of each school. It should match. And when you are done, you are going to write a sentence. I know the first part of the sentence. In 20 years, both schools will have blank number of students. You have to find that number and write the sentence. I'll say it one more time. In 20 years, both schools will have blank number of students. Pause the video, find how many students they have. Okay, last problem for today. We're going to put it together and we're going to go ahead and solve the rest of this problem. Imagine that your school planted 2 trees when it was first opened. One tree, a ficus, was 6 feet tall when it was planted. The ficus was 6 feet tall and has grown 1.5 feet per year. The other tree, an oak, which was grown from an acorn. Does anyone know how tall an acorn is? 0. An acorn is 0 feet tall and has grown 2 feet per year. That's a pretty generous growth rate. When will the trees be the same height? So notice you don't really need this plus 0. Okay, what is our first step? When we want to know when 2 things are the same, we set them equal to one another. 1.5x plus 6 equals 2x. First step, side flip. Minus 1.5 minus 1.5, and I'm left with 6 equals 0.5x. The reason why I did this part is because some of us are slow to remember how to get rid of a decimal. We're used to regrouping with whole numbers. If we're regrouping with half, remember, this says half of a number is 6. Half of what number is 6? The other way that you can do this is divide by 0.5. Divide by 0.5 on a calculator. When you do this, you're going to get x equals 12 years. Okay? Now, 12 years, you need to take this back and you need to plug it in and you need to tell me how tall will both trees be and write a sentence. In 12 years, both trees will be blank feet tall. Thanks for tuning in today. We're going to continue to practice solving systems of equations algebraically to figure out when will they be the same. Thanks for coming today to lesson 5.2.3. See you next time.